Hello everyone. So in the previous few presentations we discussed about the voltage and its sources, current and resistor separately. Now it's time to combine these three factors by using a very basic law which is called the Ohm's law. This Ohm's law provides base to electricity, and this law is applicable to any network in any time frame. It is applicable to DC networks, to AC networks, and to microwave circuits and any response of the system and etc. There are a lot of application of Ohm's law. To derive the equation for Ohm's law, we can use the equation which is used in every physical system, which is very basic equation which states that the effect of any system is equal to the cause which produce this effect and the opposition to this effect. To derive Ohm's law from this basic physical system equation, let's consider a simple circuit in which we have a resistor R, which is connected across the terminals of the battery. Through conducting wires. So as we connect the resistor across the terminal of this battery, so as a result the current will flow in this conducting wire from the positive terminals through this resistor and goes toward the negative terminal of the battery. So as a result there will be the voltage drop across this resistor, which is we represent in this case with VR, which represent the voltage drop across this resistor, and the polarity of this resistor can be derived from the flow of this current. So conventionally the current entering to the positive side of the resistor and leaving the negative side of the resistor. So here we have basically this voltage source represent the cause which produces the effect, which is current, and the opposition produced to this current is the resistor. So basically we can say that the voltage is the cause which produces the effect, which is current, and this resistor provide opposition to the path through which this current is flowing. This is basically the opposition to the flow of current. So instead of this basic equation we can use, or we can write, the effect is basically the current which is produced by the cause, and the cause is voltage or potential difference of this voltage source, and opposition is basically the resistor or the resistance to the path of flow of current. So this equation is basically represent the Ohm's law. The mathematical relation for Ohm's law is I is equal to V divided by R. The statement of the Ohm's law is, so basically the Ohm's law states that the current is directly proportional to the applied voltage. So the current is directly proportional to the applied voltage. To remove this sign of proportionality, we introduce this term called the opposition, which is resistance. So I is equals to 1 divided by R into V. This 1 divided by R represents the opposition to the flow of current. So from this equation we can simply say that the current is directly proportional to the voltage, or current is inversely related to the resistance. So as we increase the resistance of this resistor, the current through this resistor will be decreases, because there will be more opposition to the current. And we can simply write down this equation as V is equals to IR. This is another form of Ohm's law. To understand the Ohm's law in a more brief way, let us draw this relationship graphically. The graph and characteristics of any system plays an important role in any physical or technical system. Through these characteristics and graph, we can find out the broad picture of any system. So for a system having constant resistance, the relationship between voltage and current can be found out by using the basic graph, which is, so the given graph will represent the voltage and current relation for a system having a same resistance or a constant resistance. So the straight line of this graph reveals that for any change in voltage and current, the value or the resistance of this resistor will be the same or constant. So for such kind of system in which the value of resistance is constant, we can find out the value of resistance at any point in this graph by using this basic law, which is called the Ohm's law, which states that R is equals to V divided by I. So if you want to find out the resistance at this point, then the voltage at this point is 5 volts and the current at this point is 1 ampere. So simply put these values here in this equation, we get the value of the resistance. So the voltage is 5 volts and the current is 1 ampere. So we get 5 ohms. So if you want to find out the value of resistance is at this point, what should be the value at this point? Then the value of resistance at this point is, value of voltage here is 15 volts and the value of current is 3 ampere. So we get 5 ohms, which reveals that the value of resistance is the same or constant if we increase or if we make any change in current and voltage. The value of the resistance will be the same. So the resistance throughout this graph is 5 ohm. So just for comparison purposes, if we compare this Ohm's law, I equals to 1 divided by R into V, with the very basic line equation, which is Y equals to mx plus C. So here C is equals to 0. So M represents the slope of this straight line. So the slope in this case, which is equals to M equals to 1 divided by R, which means that, or which states that if we increase the value of this resistor, so the slope of this line moves towards the voltage axis, and if we decrease the value of this resistor, then the graph or this straight line are moved towards the current axis or the y-axis of this graph. So for the comparison purposes, if we have a resistance value of 1 ohm and a resistance value of 10 ohm for the same system, then the resulting graph for 1 ohm and 10 ohm will be. So this graph reveals that as we decrease the value of the resistor, the graph becomes more steeper towards the y-axis or the current axis of this graph, and if we increase the value of this resistor, then the graph moves towards the voltage axis or the x-axis of this graph. So it's all for today's lecture. If you have any doubts, ask in the comment section. See you in the next one.